All right, so they give you... The nice thing with this problem is they give you the polar form already.
You mean the Z2?
Yeah, these are in polar form, right? All right, it's 54. Cool.
Did you leave out 3 and 5 outside the parentheses?
Do what now?
On 54, it's
Oh, no, you're looking at 55.
oh, my bad, good.
Is the question 54?
It is 54. I messed that up. I wrote the 5.
Well, let's do this one. This will be a nice review. In general, Z1 times Z2, when they're in polar form. So, I mean, Z1 is R cosine theta 1 plus I sine theta 1, and Z2 is the same thing with 2's. What's the rule for that when you multiply?
Just add the cosines together.
What do I do with this poor little dude?
R1 by R2.
R1 times R2, cosine theta 1 plus theta 2. Cool. And of course that leads to the rule for raising it to a power, right? Because then you'll just be adding the same angle to itself, and that's why there's an n theta in that equation. Cool. And remarkably enough, when you take the root, it's divided by n instead of multiplied by n. Okay. It's crazy how there's little nifty little symmetries like that to make it easier to remember. So on this problem, that's what I do. What's R1 and R2? It's awesome. 1 times 1? 1. Good. And then I get cosine of pi plus I sine pi. That was not too bad, right? And what's cosine pi? And what's sine pi? 0. Is that right? What are these, by the way? This is not part of the problem, but what is that in a plus bi for? Don't make too much out of what I just said. What is that in a plus bi for? What is cosine pi for? Yeah, converting it back is easy. Just do what it says. Sine pi over 4 is no way. All right. And then this guy would be, careful, negative. And then this is plus again. You guys semi with me here? Yes, sir.
Do you want us to go all the way down to -1? Because I know for the problem it just wanted it.
Oh yeah, you can stop here, but I'm always curious what the hell that really is. All right? And if you know how to do complex number stuff in your calculator, you can actually plug it in and check it. Or you can do it by hand. Foil that bad boy out. Make sure that you get -1. Now, do you guys notice that root 2 over 2, there's one in there, and then there's another one in there. So I could take it out. I get 1 plus I, and then I get -1 plus I. Let me stop there. That's the kind of manipulation that a lot of people have trouble with. You see where that last line came from? Did I do it right? Yes. All right. I took a root 2 over 2 out of that one, and a root 2 over 2 out of that one, so I got 2 root 2 over 2's out front. And then this is kick-ass. That's like a difference of squares, right? So then I get, what's root 2 over 2 squared?
1/2.
1/2. And here I'll get -1 plus, minus I plus I, so I get -1 plus I squared, which is -1. What's 1/2 of -2?
-1.
Holy shit. Well, of course, duh. I mean, let me not say duh, that sounds horrible. I'm saying duh to me. I'm making a big deal out of this when actually, well, when you multiply these, you get -1. That's what we said. So what do we get when we multiply them? We got ooh, right? But still, it's a way to check yourself. Maybe. Just
For 10-1, number 65, just getting it started.
before I get too far, there was a Z1 divided by Z2 part to this. And when you divide,
Minus
yeah, what goes out front though?
R1 divided by R2.
That's great. And then you get cosine of
Theta 1 minus theta 2.
cosine sine theta 1 minus theta 2. So real quick, this will be 1 divided by 1, 1. And I get theta 1 was pi over 4, so I get cosine of pi over 4 minus 3 pi over 4. What's pi over 4 minus 3 pi over 4? Negative 2 pi over 4, negative pi over 2. What's cosine of negative pi over 2? What's up?
0.
0, cool. And what's sine of negative pi over 2?
Negative 1.
So I get negative I. And you can do the same thing if you divide those, you should end up with negative I. Okay? Sorry. Who did I just cut off? Yeah.
65 and 10-1.
Oh, okay, cool. All right, here we go. Yeah. Every math student, no matter what level of math you're in, there's always that word problem section that's coming. And so here's some word problems with these. And these are systems of equations. I know there's going to be word problems for those, right? Or you should remember, you should expect them. A researcher is testing niacin and retinol. Sure. She feeds one group of lab rats a daily diet of school food. Of precisely 32 units of niacin. All right, so let's see. So she gives group 1, we'll call it group 1. The group 1 rats, they get 32 niacin and 22,000 retinol. Blah, 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 blah. She uses 2 types of commercial pellet foods. Oh, okay, so there's only one group. Food A, oh boy, here we go. So food A contains 0.12 units niacin. Yes. 100 units retinol. And food B contains, oh boy, 0.20 units of niacin and 50 units of retinol. Okay. So see, as I'm doing this, I don't have to have a clue about lab rats, their diet. I don't have a clue about what retinol is. You can Google it if you want to, right? Sounds like the stuff I used when I was a teenager for my acne, retinol. So I don't know why they're ingesting this, but oh well. Right. What's that?
It's vitamin A.
Vitamin A? But the name of the medicine was like retinol or something,
Yeah.
if I remember correctly.
But it's really dry.
Oh, retinol is vitamin A.
Yeah.
All right, thank you. There we go, cool. Now we know. I had no idea. Why would they call it retinol? Who knows? Mr. Retinol needed something named after him. So, what the hell? So I just collected everything that was important in that problem mathematically, right? This is the important stuff mathematically. How do I convert this into a system of equations?
Now that I see it, I think I got it. Would it be 0.12x plus 0.2y equals 32, and then the other stuff for 22,000?
Yeah, because now you've got, well, let's call it A and B. Is that cool? So, blah, 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 blah. Blah, 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 blah. Yeah, good. I got it. So, like, 0.12a is what? Represents what? So this is one pellet of food A. So it represent the niacin that the rats get from food A. How much total niacin do they need? 32 units, right? This sounds weird. How many units of niacin have you had today? I don't know. Not enough. I don't feel right. So if they're supposed to get 32 units total from food A, they get 0.12. So 0.12 times A, because they're not going to just eat one pellet, they're going to eat several, right? So the unknown is how many pellets of each. So 0.12 times the number of pellets of A, plus what?
0.2.
Yeah, plus 0.2 times the number of pellets of B has to give them 32 units of niacin. And now you set up another equation that deals with retinol. You guys kind of with me? So this is a system of equations. There have to be, for two unknowns, there has to be two pieces of information. In this case, they were grouped by niacin and retinol, to be honest. Here's the niacin idea, and now you want to write an equation for the retinol idea. And then you can substitute, eliminate, whatever you want to do. One thing you cannot do if you know how to do this is make a matrix and put it in your calculator and have the calculator solve it. You cannot do that. Sorry. Oh, had their dreams crushed. Again, if you do that, your calculator passes the class and you have to take it again. Calculator goes, bye, man. Off to calculus. That wouldn't make any sense, so don't do that. That's stupid. Alright. Is that cool? Do you guys see that? It's a little weird when you first read through it. It sounds like there's just way too much going on, but you're desperately searching for the connection. What is equation 1 all about? In this case, equation 1 is all about niacin. Equation 2 is all about retinol, and that's how you kind of set it up. Doing this is important. I don't know if you guys, nobody ever seems to do this, but just summarize everything that's important mathematically. The rest of it is important, just not mathematically. Mathematically, that's all that's important. Alright, cool. I like it.
And the test won't have, or the quiz won't have 10 on it, right? It'll just be 8.
Yeah, the quiz is just going to cover 8. Yeah. I think it's enough stuff. Yeah.
Yeah. On 8.1, like the last problem on it, it was like, it said to use the law of cosine try to prove this, but it ended up using the distance of that. I wasn't kind of sure.
Number 69?
Yeah.
Alright. We did talk about that a little bit, but just to remind you guys, because some of you are just kind of writing the result as if it's obvious or something, which I appreciate that, but it's not. So we have two polar points, and they could be anywhere. I don't care. We'll put them there and there. So here's one polar point, R1, theta 1. Here's the second one, R2, theta 2. And I need to figure out what the distance is between them. Cool. So I have this, and I know the length of that. And I have this, and I know the length of that. Are you with me? So what is the length of this? R1. What's the length of this? That's crazy. And what's the last thing I need for the law of cosines? The angle between them, right? And I know what this angle is. How would you get that angle? Theta 2, you guys, theta 2 would be all the way here, right? So this would be theta 2 minus theta 1. Cool. So this angle is theta 2 minus theta 1. And you guys see in the results, do you see theta 2 minus theta 1? Yeah. I do. So that's how I know I'm on the right track. Now it's just a law of cosines problem. That's it. It's just a law of cosines. Just set it up directly. Call this, amazingly enough, call this D. The distance you want is between those 2 points. And then it becomes really simple. But you have to at least draw the picture. Why did I put the point there and there? I don't know. It's just where I happen to put them. You draw a picture to kind of anchor. So no matter where I would have put them, I don't care where I would have put them, it would have been exactly the same idea. Do you guys understand that? So I just draw a picture and I put them somewhere just so I have something to anchor myself visually. It's always nice to have that.
So now you just put that in the law of cosines?
Yeah. Because law of cosines is all over this bad boy, right? D squared equals R2 squared plus R1 squared minus blah, blah, blah.
Yeah, because I was in tuition, when they got the solution manual, the solution manual, they did it with the distance formula, like a really long way. I don't know why.
Oh, screw that.
Yeah, exactly.
That's foolish. Why would the solution manual
explain
to maybe that's why other people did it that way instead of doing what the book actually says to do?
Yeah, that's
really stupid.
Yeah.
The guy who made the solution manual, I don't like that instruction. I'll do it the long ass way. Screw that guy. If he wants to do it the long ass way, it's his choice.
But you only have to do it once.
Aw. Well, you only have to do it once. You're going to do that over and over again? Yes, sir.
This is not necessarily a question or a comment. I think everyone here agrees, or everyone mostly has had a job before, and it's never a good time to tell somebody they're doing a good job, regardless of what our individual grades are. I think, and I think most of the people in this class think they're a good professor. We talk after class, and I appreciate it. I think you're a good professor. You're one of the better ones I've had.
Thank you.
You're welcome.
Although, for some reason, I have the highest rate of withdrawal.
That's okay.
Among all the pre-calculus, I think I have the highest.
It's not about you. It's about
crazy.
the subject. It's the subject, not you as a professor.
Well, a few of the people that dropped actually found out, they figured their major out, and they figured out they don't need pre-calculus.
Yeah.
So they dropped, so I don't count them. But some of them just, well, and the average of the people that dropped, because I was curious about this, is like a 66. But a few of them had in the 80s, so I'm always worried about them, but I mean, what can I do? Well, okay, thank you.
You're doing good.
All right, thank you. Cool. So I got a little cushion now. I can be really sucky for a while. Just come on. Is that what it is? Yeah, he was all right. All right. Anything else from the homework? Yeah.
Section 8.4, question 62.
Oh yeah, this one's a nice one. This one's gross. This one's gross. I like this problem. I would. So two circles of radius A and B are centered at the origin. For me, that's really, really good circles. Blah, blah, blah. As the angle theta, okay. Increases the point P. Choose the parallels between circles. Okay. Let me see what they're trying to say here. So we have, as you let theta increase, so this one's got a radius of A, right? The other one, B. And this one's got a radius of A. And as I let theta change, the way it traces out, the way it determines where this point P is. Now this is really difficult to see what's going on here, but it's sort of like when I showed you the spirograph thing and you put your pencil in the middle. And then you went to the point, the circle. So I don't know if you guys remember. I could pull it back up, but I don't want to. You pick a circle, you pick a little place to put your pencil in the middle. You have all these different holes you can put it into, and then you start rotating, right? So what they're saying is, notice how it determines where P is going to be. It makes a little right triangle here, and then that's going to be the point P. So if I change theta by a little bit, I need a third color, which I don't have. Dadgummit. Oh well. If I change theta a little bit, now P is going to be, you can do it, Jeff. Straight down. and then straight out. P would be there. So and if theta is here, P would be right there. So what I'm going to end up with is an image of connecting where P is as I let theta change. That's some weird shit, right? Let me try one more location for. Here's the weirdest one. Let me see if you guys get this. Do you guys? All right. So the main idea is if I let theta change, wherever it hits here, I'm going to go straight out, and then I'm going to keep going, then go straight down. I'm going to make a nice right triangle, and my point P is going to be right at the corner of that right triangle. So as I change theta, I'm going to have to make that right triangle again, figure out what P is, and then connect it. I'm going to make a series of points and then connect. I'm going to end up with an interesting shape. You guys kind of with me? So here, I would go, again, how did I get the point to be there? I went straight out from this, so I go straight out from this, and then I drop, well, there's nowhere to drop from. And if I make theta just a little bit bigger, if I make it here, then the right triangle would be this. And do you guys see how it's just going, do you guys see how that point's going to trace out some shape? All right, let's do a couple more. This might be helpful. What would happen if I'm right here? What would happen if theta was pi over 2? Right on what line?
The first circle.
Yeah, because if I go here, if theta is pi over 2, then I start at this one and I go out. There's nowhere to go out, is there? So whenever I get here, I go out to this first circle and then I go out. But there's nowhere to go out. There's nowhere, it would just be right there. So see, now it's tracing this point here. And then I can continue on the other side. All right, maybe. That's exceptionally freaky. So this idea, you can have a circle rolling on another circle and plot a point P as it rolls, and you get an interesting shape at the end. It's very related to the gear within a gear, or gear sitting outside of another gear with the spirograph thing that we looked at. Kind of similar way to create shapes. And the hard part, of course, is coming up with the equation that models that shape. And that, of course, is the question, I hope. Yes? Find a parametric equation for the curve. I like it. So, what point is this? I like it. Be more specific. That's the name of the point. What point is it? There's two parts to a point. It's the point what? It's generic. Well, we're in the parametric. Right? This is section 8.4. Please tell me I'm in the right section.
Yes.
Oh my God. If you would have let me go all that far, I would have had to say, well, you're a bad student. All right. This point is xy. It's just some xy point, right? Where x is some function of theta and y is some function of theta. Now, let's look at a couple of specific examples. When theta is 0, what's x and y? When theta is 0.
1 and 0.
And again, remind me, how far is this? B. And how far is this? A. So the point's here, right? So what's x? A. And what's y? 0. What if theta equals pi over 2? Another extreme. I'm there, right? What's that point? Yeah, what's B?
Y.
Y is B? X is 0. Cool. Alright. So we have some of those. Now here's the key. Let me try to redraw this picture a little bit. Just the important part. So what I've got is, when I'm at some arbitrary theta, I want to figure out what this is and what this is. All right, let me stop there for a second. That's the trick. So the real first important step on this problem was a really small step. Was this. Realizing that that's the question. They're asking you, what is the point at some arbitrary angle? If you can figure out what the point is in terms of theta, you've got the parametric equations. X equals a function of theta, y equals a function of theta. So what's x? How do you get to x? There's two parts to it. And let me blow this up right here. Here we go. Let me see if I can do this. So here's the inner circle. I need it. And here's this here. And this is the outer circle. So here's x. Here's the origin, right? This is 0, 0. So here's x. What's x made of? This is a weird question, I know. But you guys see two right triangles? Isn't x made of this piece plus this piece? Alright. And what's y made of? Y is a little bit freakier. Y is made of this piece minus this piece. Right? This here is y. Do that for y. This here is y. This here is x. Oh, shit. Well, let me do one little piece of this. And then that's all I'm going to do. Because you have to try this kind of problem out. And this is where students are less and less able to do this. You feel like you haven't been told how to do this. Well, no, you haven't. There's no way to tell you how to do every possible problem that could ever come up in any situation. There's no way to do that. How big would that book be? It wouldn't fit on the frickin' Earth. Right? You have to have it stationed at Jupiter or something. I'll go look on page 18 quadrazillion to see how to do this. Do you guys understand what I'm saying? There are basic ideas that you apply to a problem. You're not going to be able to see a problem beforehand. So how do I make x? How do I get this? What's true about this triangle? What do we know about this triangle?
It's a right triangle.
I like it. It's a right triangle. What else do I know about this triangle? Again, it's the triangle I stole, and this is the little triangle I'm looking at, that one. What's the hypotenuse?
A minus B.
B. The hypotenuse of this triangle is B. So then what's the x piece? We put theta a little smaller down here. What's the x piece of this triangle?
Cosine.
B cosine theta. Yes, no, maybe so. Yes, no, maybe so. What angle is this? It's got to be theta also, right? No. It's got to be theta. Parallel lines, transversal. Oh shit, little geometry sneaking in. Oh, scheiße. So this is theta also. But what is, now here, somebody was ahead of me. What is this hypotenuse? A minus B. So what is this piece? A minus B cosine theta. So what's x? D cosine theta plus A minus B times cosine theta. Now, of course, I actually did this a lot harder than it needed to be, but I did it on purpose so that you could see what you have to do for y. Real quick, I could have done this whole problem. What do you get? What happens here? What happens? You can do it. The B's cancel. Right, because it's minus. So I get x is, and of course it is. This is theta. Look at the big ass right triangle. I got a big ass right triangle. What's the x piece? This whole thing is A cosine theta. There. You have to do a similar thing with the y pieces. Figure out what the whole thing is, figure out what that piece is, and subtract them to get the y piece. I don't know. That sounds like it might be part of it. But that's enough. That's plenty. You guys should be able to attack that problem now that you see what the problem is asking you. That, of course, is always the first hardest step. What the hell are they asking me to do here? That's always the hardest step, right? If I could just figure out what they're asking me, I could start to do something. And that's what they're asking you. And then when you figure out the equations, it's kind of cool. Then you can graph it and see what this thing is going to look like as it traces it out. That's nifty. Alright, that's enough of that problem. Anything else? Okay, cool. We'll get back into chapter 10. So no questions on 10.1, 10.2? I'm hoping those are pretty much just review. I mean, I focused yesterday on the weirder aspects. And it's not going to be every single problem that ends up with a parameter, but that's the only thing that should have been kind of new. Solving system of three equations should not be new. I had that handout I gave you guys. If you didn't get one, that's too bad. I mean, let me see. Oh, I have some. Anybody need that handout from yesterday? For some of you guys, this is probably nothing you needed, but okay. Alright. So the only new thing was, it's not enough to stop and say there's an infinite number of solutions. You must be much more specific now. Right? And I showed you a couple ways that could happen. I even showed you a situation where we had two parameters, which is not going to happen. If I remember correctly, it should not happen in the homework. It should only have one parameter. So can somebody remind me, if I have one parameter, I don't care how many dimensions I'm in. If I have one parameter, what does that describe? A line. It's crazy, right? A line has one true independent variable. So I don't care how many variables, I could be in 5-dimensional space. Yeah. 5D. I want to see that movie. What the hell is that? What kind of contraption are you going to wear? You're in 5D. Everybody's brain explodes and they say we shouldn't do this.
That's the thing Professor X is wearing.
Oh yeah?
That's the
oh no, not the Cerebro.
There it is.
Oh dude. Well, only his brain can take it. What was I about to say? I forgot. Oh, so if all of these are actually dependent, let me give this a different letter. This T. Let's just call this one B. So if they're all really like T minus 1, 2T, 3T plus 1, natural log of T, and square root of T there. That describes a line in 5-dimensional space. Whatever that would be. If it takes two parameters, it defines a plane. Makes sense because there's 2 dimensions in a plane. If it takes 3 parameters, it defines a cube kind of thing, like a volume, right? It takes 4 parameters. It's a hypercube or something weird, right? That's enough of that. Let's stick with 3 dimensions at most. All right. Google it. It's actually a freaky ass movie too. All right. One of the lesser sequels to Cube. Yeah. Sorry, it's enough of that. Sorry. All right. So if there's no specific questions about that new idea of how to be more specific with the infinite solutions, I'm just going to get into the next couple sections. All right, cool. Let's do it. So 10.3 introduces the idea of matrices. And a matrix in math has nothing to do with, Keanu Reeves and there is no school. Has nothing to do with that. What the hell is a matrix? Who's done them before? Cool, a few of you guys. Describe a matrix. I just want to hear what you say. Describe what a matrix is. I love it. Kick ass. It's actually a really good way to do it. The most important thing in solving a system of equations are the coefficients, right? They're really what guide me in what to do. So if I had to solve this equation, if I had to solve the system of equations, the quickest way to do it would be to do what with this one? Double it, because I looked at the coefficients. Now, I had to make sure that they were the same variable, but the minute they're the same variable, all I care about are the coefficients. So what a matrix does is it says, and we've done, no, we haven't done that yet. That's in our future. We haven't done synthetic division yet. Yes, we have. Totally. I'm sorry. Many classes at different places. synthetic. Synthetic division was all about getting the variable out of the way, because that just made the problem long as hell. Synthetic just focused on the coefficients. So matrices themselves are sort of like that on one level. So the matrix, what this would look like in matrix form would be and I might do that just because it's out of habit. That separates this, which is the variable coefficients, from this, which is the answer coefficients. Right? You guys see what I'm saying? All right. How are we doing just on that level right there? So it's sort of like the same idea as synthetic. Get rid of the stuff I don't really need. I have to make sure that this is the x's, this is the y's, this is the numbers before I make it into a matrix, which makes sense. The minute I have that, I don't need them anymore. So for example, to solve this, I really should have made sure, screw it. It would have been nice if this would come out to something nice. Will it? Let's see. No, it won't. That's too bad. Make this a 7. I think that'll make it work. Let's see if that makes it work. Alright. Let's see if you guys can figure out how to solve this. How would I solve, again, remind me, how would I solve this? What would be the first step? Yeah, I would double this one. So then I'd leave the first one alone. And I would double this. Right? Cool. And now that verifies that it will come out. As a matrix, here's the beauty of the matrix. Here's what I do. Let me see if you guys, well, let's see. Oh, no, screw it. I'm going to show you the shortcut from the beginning. I'm not going to do it the long-ass way, because then you're like, what good are matrices? Right next to this, I'm going to put what it would be if I doubled it. Now watch. After I double this, what do? Add them, right? That's what you do. That's how they cancel. It's because I add them. So every row in a matrix, in what we're doing with matrices right now, every row represents an equation. And if I can add two equations together, I can add two rows together. Now, instead of changing this row, are you guys semi-cool with this? Instead of actually changing it and rewriting it and having to write the damn matrix 18 times, I'm just going to put up in the corner what it would be. So instead of actually rewriting shit, I'm going to just put in the corner what the coefficients would be. What's negative 2 plus 2? 0. 8 minus 1, 7. 14 plus 7, 21. And then the first equation can stay the same. Why not? And then, of course, if I add these, I'll get 0. I get 7y equals 21. So that is represents 0, 7, 21. Now what can I do? What's there that I can do? Yeah, I could divide by 7, just like I would do there, divide by 7. So here if I divide, so I got to keep track of what the hell I'm doing. So what did I do from here to here? Tell me in terms of rows. What did I do from here to here? Multiplied what by what? Good, so twice row 2 plus row 1. And where did I put the answer? Row 2. Do you guys see that? Maybe I wrote that too small, but do you understand? Let me write it bigger. So we did twice row 2 plus row 1, and I put the answer in row 2. Now, the reason you do this is twofold. So that I can grade your shit. If you make a mistake somewhere and you don't write that, I'm not going to take a lot of time to try to figure out what went wrong. If you write this, then it's easy for me to think, oh, you shouldn't have done that, or oh, you meant to multiply by 3, but you didn't do this one by... You understand? It's easier for me to give you partial credit. You don't write this shit, I'm lost, I'm not going to stay lost, I'm just going to move on. You with me? Because I have that option. Now, the second reason is so you yourself remember what the hell you did. You go back to your homework and you're like, how did I get that? No, if you give yourself little notes, you'll remember what the hell you did. All right? Now, what am I about to do now? What am I going to do to row 2?
Divided by 7.
Yeah, so row 2 divided by 7 to row 2. Now, the minute I made a 0 here, why is that nice? What does a 0 represent in a matrix? What is a 0? What does that 0 mean? I killed the x variable there, right? And what's the whole point of solving a system of equations? Too many frickin' variables. The number of variables is too damn high. So I must kill some of them, right? So I desperately want zeros. So what's over here? How many variables are still in row 1?
2.
That sucks. I want to kill one of them. Which one can I kill?
1.
I can kill that dude, right? If I do what with the rows? So if I take row 1 plus row 2, where am I going to put the answer? Yeah, row 1, right? Row 2 is beautiful. What does row 2 say? Y equals 3. I don't want to touch row 2. It's beautiful. I don't want to lose zeros. I don't want to overwrite things that are done. You guys kind of with me? So I want to put the answer in row 1. So if I add these together, what do I get?
2.
That's crazy.
0.
10. And then 0, 1, 3. And then the last thing I do is take row 1 and divide by 2. 1, 0, 5. 0, 1, 3. So what's the answer? X equals 5, y equals 3, or otherwise known as 5, 3. Crazy. Now, I will give you this. For a 2 by 2 matrix, the matrix way to solve the system is at most as good. It's actually quicker to do this. But a 3 by 3, it's a little bit quicker. And then, can you imagine a 7 by 7? I would never, ever want to solve that without a matrix. Yes, sir?
After you divide it by 7, and I guess the third row, why don't we just plug in 3 for row 1?
Yeah, we totally could. And that's one way to do this. This is called triangular form. Do you guys see why it's called triangular form? There's a triangle of numbers here. Woohoo! This is upper triangular. Yes?
So you do all this to go through 1, 0 pattern at the end, right?
Beautiful. I love it. So I want that to come out naturally from doing this. So now I see my goal. I want you guys to go all the way with these matrices. What I mean by that is don't stop and start to back substitute. That is a totally valid method. But I want you to get really used to I want you to get totally used to getting the matrix all the way down. Why? Because that's the new thing. I know you can plug 3 in for y. I don't need to see you do that. I need to see you work with the new thing. The matrix. Some of you guys are like, it's not new to me. I'm like, I don't care. It's new to this class, so you will do it that way. All right?
Can you explain the fourth one again? Like how you did the R1 plus R2?
Here?
Yes.
So 2 plus 0
Just add
is 2. Negative 1 plus 1 is 0. 7 plus 3 is 10. Because I add them and I put the result in the row 1. Now, real quick, right here, I could have added these and put the result in the row 1 and kept row 2. It doesn't really matter. You guys kind of with me? That's why you want to tell yourself where you're putting it. Sometimes it doesn't matter, and sometimes you don't want to lose one of the rows because there's a really good row. I don't want to lose a really good row. All right, this is our first little foray into this, especially if you haven't never seen these before. This is the first immediate use of matrices. What I want you to understand is this is like 0.1% of the use of matrices. This is the most immediate one. This is the one that's going to be involved in your life for a while. But this is only one little smidgen of a piece of what you can do with matrices. So does anybody here have to go up to like linear algebra even? Dude, you learn. Engineers? Some of you guys? Okay. Linear is awesome. Linear is all matrices. And then you're doing like n-dimensional space and shit. Oh yeah, dude. Sorry. I get excited about it. I like linear algebra.
For this really hard class that our friends that
Yeah, it is.
the average of the test is like 50.
Totally. Yeah, sorry. It's very proof heavy. It's very theorem heavy. It's very ambiguous. That's why I love it. It's yummy. Anybody listen to Pandora? Anybody use Pandora? What is it nowadays? Spotify? You guys use Spotify instead? Or whatever? All right. Remember Napster? Anyway.
Yeah.
Pandora uses linear algebra to figure out... I know how to figure out the distance between 2 points in two dimensions, right? Pandora uses linear algebra to figure out the distance between 2 points in 500 dimensions. So what it does is, when you say you like a song or you like a band, it actually plots in 500 dimensional space that band, all the attributes of that band or that song, and then it says, well, this band is not very far away from that because I've calculated the distance between the two. I'm going to play that and see if you like it too. And if you don't like it, it'll maybe go the other way. It'll say, well, maybe it's this part of the thing you like. I don't know which of the 500 dimensions you like. Let me change it a little bit. You guys semi with me here? So if you ever use Pandora, when you hit like, it's collecting data on you. And then it gets something that's close to the things you like. And it uses linear algebra to solve it. Anyway, that's enough. So that's one of the first things I tell my linear algebra class. And you guys got a little sneak peek. Is that fact? Yes, it is. It does have a use. Okay, so let's do let's try a 3 by 3 matrix. And somebody already pointed this out. Do you notice how this is naturally a goal? Why is that such a nice form for that to be in? Because it says x is 5, yeah, so forth. So if I had a 3 by 3 matrix, and oh, before I get too far, let me talk about dimensions of matrices. So this would be a 2 by 3 matrix. You with me? Like a 2 by 4 piece of wood. 2 is the number of rows. 3 is the number of columns. So we always say it in that order, 2 by 3. And there you go. So I don't have to draw anymore, do I? All right, so a square matrix. What do you think we call a square matrix? It would be, for example, 4 by 4, 5 by 5, 6 by, they just have the same dimensions, because then it would be square. All right? All right, how are we doing so far? Semi-decent? All right. So I will sometimes call a problem like we just did a 2 by 2 problem. What's kind of wrong with that? And then I got to correct you on why it's not wrong. So the problem we just did, I forget it now. What was it? It was
2x minus 5 equals 7. Plus 4 equals 7.
Negative x plus 4y
equals 7.
Equals 7, okay. I call that a 2 by 2 problem. And the reason I do that is because this would be the main matrix part. This we call augmented. So when I write the matrix for this system of equations, there's stupid y. This represents the variables in the problem, right? And this is just some more terminology. Then I augment, so this is called an augmented matrix. Augment, what's that word augment? Do you guys know? Add to, exactly. So I always think about like cyborgs, and you're augmenting your augmenting yourself. The last thing was, but we'll get past that. So that's why I call it a 2 by 2 system, because it's 2 equations with 2 unknowns, 2 by 2. But the matrix, when you actually create it, is what dimensions? 2 by 3. I like it. Cool. Because it's been augmented with the answers. Sweet. So just in case I say that and you get thrown off and you're like, what the hell is this guy talking about? If I say a 3 by 3 system of equations, it's actually going to end up being 3 by 4, because I'm going to add the answers in it. Cool. So if I have a 3 by 3 system, yeah, what's my goal for the non-answer part? What's going to be my goal? What do I mean by that? My goal here was to get to 1, 0, 0, 1. What's my goal in a 3 by 3 system? 1, 0, 0, 1. Ones. Good. So just diagonal ones, right? So what's my goal in a 70-dimensional system? 1, 0, 1, yeah, good. So the diagonal is ones. I love it. Because you're killing all the other variables. And then if this is A, B, C, then X would be A, Y would be, Z would be C. I like it. Yeah, so that's my goal. So what I want to do is, if I can, I want to move anything that has a 1 to the first row and then use it to kill the other 2. I often think of this as my laser. Right? What do we use lasers for in surgery? We pinpoint a thing and we kill it. There's a little tumor and it's attached to something I don't want to kill. Laser. Right? Sorry. It's strange. Why don't you in the laser get a room? Whenever I say this, that's the scene I think of. And if you had no idea what that was from, there you go. Thank you. Catch up. So let's see what the hell this is all about. Let's try this out. And I'll tell you what, I got a handout. We're going to do it up on the board, and then I'm going to give it to you. So if you don't want to write, if you just want to watch, I'm going to give this to you anyway. It's got it all worked out, right? So let's do this system of equations here. Alright, so take a second and put that into matrix form. Augmented matrix. Oops. What happened?
For the third equation.
Oh, thank you. Okay. That would have been you. So be careful. I can't remember the book. I think sometimes put things out of order. I can't remember now. They do that. Just got to make sure everything lines up before you make a matrix out of it. Of course, this shouldn't be too bad. What would that matrix look like?
Negative 2, 1, negative 3, negative 4. 1, negative 3, 1, negative.
Kick ass. Alright, so this is a nice one to start with. Now, one thing you got to realize is, what are you allowed to do? Anything you're allowed to do with two equations, you're allowed to do with two rows. So, would I be allowed to switch these two equations? Yep. Totally. Because why was they giving it to me like this? Because it just was. It's the way they came up with it. So I can totally switch two rows. So if the 1 would have been here, and I know my goal, I would have switched the rows and put the 1 there. You with me? If there is no 1, oh, let's do that. We'll talk about that in a minute. 1s are nowhere near as important as zeros. If this would have been a 2, I could have still used it to kill these two things, right? That's what's important. Zeros are important. 1s are nice because they can become anything else. If there's a 5, a 1 can become a negative 5 and kill it. But if I don't have a 1, I can live with that. I can do what I need to do to make a 0 show up. Zeros are the most important thing because that means a variable has died. Right? And they must die. Alright, so what's a good first thing to do here? Say it one more time.
Multiply row 1 by 2.
Good, right. Why would you multiply row 1 by 2?
To get rid of row.
Because then you can laser this guy away, right? Can't say the word laser right anymore. So if I did laser, exactly, a Death Star, cripple. So if you do twice row 1, say it for me.
Twice row.
Plus row 2.
Plus row 2. Where are you going to put the answer? Why would you not put it in row 1? What's row 1 got that we want?
1.
Yeah, I'm not going to mess with that. So you got a lot of choices you can make, which kind of sucks. But I know I don't want to screw with that 1. Why? Because I want to use it next to kill a 4. If I overwrite the 1, screw me. I just screw myself over. Alright. So I'm going to show you the ultimate shortcut. Because matrices are supposed to make the work quicker. If you keep rewriting the damn matrix over and over, it's not making anything quicker. So let me see if you guys are able to handle this. I want to put the answer in row 2. So if I double row 1, I'm going to get what? 2. Bless you. Negative 2. 4. 6. You could rewrite the whole matrix. You could write that new row in there. But why would you? Are you guys with me on that, what I just did? Is everybody... It's okay if you're not, because if you're not, at least 8 other people are not also. So you could speak up and be their hero, or just nod your head and pretend. Does everybody understand what this is all about? I'm very cool with the fact that I can do that. Because it's equivalent to doing what? It's equivalent to multiplying this by 2 But then I want to divide it by 2 immediately. Because what's the only reason I'm multiplying it by 2?
To get rid of it.
To kill that. The minute he's gone, I don't need it multiplied by 2 anymore. So what I'm doing by doing this is what it would be, but I want to keep it the same. Because then I can use the 1 to kill the 4. Alright. You guys kind of with me? Alright, good. Okay, so what do we get in row 2 then? 0? Negative 1? 1? 2. And row 1's the same. Now here's the utility of this. So I don't need these anymore, do I? Now, before I write row 3, let's go ahead and do it. What would I do to kill this guy?
4R1.
Yeah, negative 4R1, right? Plus R3. Put the answer in R3, because that's where I want my 0 to show up, right? So what would it be if I multiply by negative 4? It would be negative 4? 4? Negative 8? Negative 12. I don't know if you're picking up on this, but the minute you forget a negative or anything like that, the whole thing is shit. Right? That doesn't mean you're going to lose all your points. The more I can see what you're trying to do, the more points you get. If you can prove to me that you understand the process, you'll get most of the points. It is so damn easy to forget a negative, or to rewrite it without a negative, or to see a 2 and it looks like a 7, and then it has no chance. You have no chance after that. So what I'm grading on is, do you understand the process of how to get there, right? If you get the right answer, that's icing on the cake. That's awesome. So let's see. What do we get when you add these, like you said? 0? 1? Negative 7? Negative 20. Alright.
Wait, are we putting what we multiply from row 1 into row 2?
When we multiply row 1,
right.
And what would we do here? We would multiply equation 1 by 2 and then add it to this equation, right? Is that right?
Yeah.
So I multiply row 1 by 2 and I add it to row 2. And that's where these numbers came from. I like it. I like it. I like it a lot. Now normally, let me see if you guys are on to this. You see how I completely finished the first column, right? The first column looks exactly like I want it to. Normally that's what you want to do, especially if you're new to matrices. You want to finish the first column and then do the next column, get the zeros, and then the last column, get the zeros, right? If you do that, if you don't do that, you get a 0 somewhere and then you lose it on the next step. And you're like, oh shit, what the hell? It's so easy to do that. If you do it more organized, you won't do that kind of craziness. Because what's going to happen now when I add these together? 0. Multiply this by 7. What's this? 0. See, they can't screw with each other now. You're not going to lose your 1. You're not going to lose your zeros because they're not going to screw with each other. What would I never do? Would I add row 1 to row 3 and put the result in row 3?
No.
Because now I would lose my 0. Zeros are most important. You don't want to lose them. Okay, maybe. And if any of you are at all interested in computer science, anybody? Computer science? You can realize that this is very easy to program. And then a computer will just munch right through them. I don't care how big the matrix is. Computer, make a 1, make everything 0. Make the second one 1, make everything 0. Make the third one, and the computer's like, dude, I got 17 over 48. But that's cool because I'm a computer. Right? We don't want to get 17 over 48. We're not going to do that shit. But a computer can just munch it up. Or your graphing calculator for that matter. Who's got a suggestion on what to do next? Now I'm going to focus on this column.
Multiply row 2 by 10. To row 3 and put it in row 3.
I see why you're doing that. I think you're doing that to kill this guy, right?
Oh, that doesn't make sense, yeah.
But no, the answers, I don't care what they are. I don't need zeros or ones over there. I'm going to focus on this next column right now. And what's kick-ass about that next column? There's a bunch of 1s and negative 1s. It kicks ass. Yes, ma'am? Okay. Alright, so there's a lot of different ways you can go. But tell me, which way can I go? What can I do?
Add 2, 3.
Is it better?
Multiply row 2 by negative 1, add it to row 1.
And I want you to realize something. That's already a 1. Couldn't I add it to both of these guys and kill those? And then I can just switch these two. Do you see that? It doesn't really matter. It doesn't really matter. But the less changing of anything, the better. Because if I multiply by a negative, I've made a case where I can forget a negative. I've made a place where I can make a mistake. If I can just leave it the way it is, it's much better. Because that would kill both of these, wouldn't it? The only problem then would be, and that's not even a problem really, it doesn't really matter if it's not exactly in this order. But this is a good place to start when you first start this. I can just switch these rows. So what I can do is I can add row 3 to row 1 and put the answer in row 1. I can add row 3 to row 2, put the answer in row 2, and then I can just switch row 3 in the middle. So it looks more like that. We'll let that sink in for a second. Some guys might realize it doesn't have to be in this order. If this one was here, it would still mean z or whatever equals a number. Who cares? But this is kind of like the order we normally think of. This is actually like the equivalent to 1 in matrix speak. This is what's called the identity matrix. And that's why we kind of want it in this form. We'll talk more about that later. Let's finish this guy out. Where did we end up at? So now we're going to do row 3 plus row 2 to row 2. And row 3 plus row 1 to row 1. We're going to use our laser to kill these two tumas. It is a tuma. Alright, let's see what happens here. So row 3 plus row 2. What do I get here? I get 0. 0. Negative 6. Who do what? Negative 18. And then if I add these two, I get 0 plus 1 is 1. 1 minus 1.
0.
Crazy. Negative 7 plus 2.
Negative 5.
Negative 20 plus 3.
Negative 17.
Kick ass. And then this row is still 0, 1, negative 7, negative 20. Alright, I'm doing it a little bit different than on the handouts, which is actually good. The handout will give you a different way to do it. Let me write that up first so we got more room. So as I write it up here, I'm going to switch row 2 and row 3. Is that cool? Why am I doing that?
Row 2 has 2 zeros.
Yeah, exactly. So I want that on the bottom. I want the one with the 1 in the middle. Sorry. I want the one with the 1 in the middle. I like that. Sorry. Sounds like a Gene Wilder kind of thing. No Gene Wilder fan, sorry. Data K? That's even further back in time. So here's row 2. Now, row 3 is now row 2. And can you guys handle this? What can I do with old row 2? What can I do with it? Yeah, 1/6, what row 3 is going to be now. So it'll be 0, 0, and in fact divided by negative 6. 0, 0, 1, 3. So what do I know?
Z is 3.
So I know Z is 3. Kick ass. So like somebody said, you could stop right now and plug 3 in here into this equation. And real quick, what equation is this? What does it say?
X minus 5Z equals negative 17.
See, so you could plug 3 in for that Z and figure out what X is and so forth. But I know you know how to do that. Ooh, you can plug a number in for a letter. Ooh, good. So I'd much rather you finish this dude out because that's the new stuff. So the book does talk about stopping and back substituting. Screw that. You know how to do that. Do the stuff you don't know how to do really well yet. So what's a good thing I could do here at the end? Yeah, now I got my laser. Ones are awesome. So multiply row 3 by
7.
Cool, I like it. So multiply row 3 by 7 and add it to row 2 and put the answer in. Good, because I don't want to miss anything in row 3. Row 3 is beautiful. I don't want to screw with it. And then I could also do what?
Multiply by 5.
Multiply by 5, add it to
Row 1.
put the answer in.
Row 1.
Okay, alright. So let's see what we get. Let's see, let's do this one first. So it's 0, 0, that's 1, 0, right? 0, 0. If I multiply this by 5, I get
5.
That's crazy. 15. So I get 5 minus 5 is 0. That's crazy. 15 minus 17? Negative 2. Cool. Don't need these anymore. Now I'm going to multiply by 7. 7 and 21. You guys with me? I don't want to go too fast, but once you see this, it's repetitive. And now you can imagine, if I did have a 5 by 5, it's not really that much more work. You just keep going. Right? But can you even imagine trying to solve a 5 by 5 the old way? You'd have to kill a letter 4 times, and then kill another letter 3 times, and then kill another letter 2 times, and then you finally got a 2 by 2. Screw that. Gee, no, don't want, no. Okay, so what are we here? We get 0, 1, 0, 1. Kick-ass. And then I still have 0, 0, 1, 3. I preserved that. So what's my answer? Yeah, negative 2, 1, 3. Kick-ass. So let me give you this. Again, this is done in a little bit different way than what I've got on the board. Wow. That took forever. On the front side, the very, very colorful one is the stuff that is that problem, exactly that problem. On the back side is something we'll do tomorrow. So I don't know if you picked up on that, but that's it. I said the magic phrase. The minute I say the word tomorrow, normally people start to back up. Tomorrow we'll... Oh, cool.